Okay, so we're going to do, this is 12.2 and it starts on 641, and we're going to subdivide a segment in a given ratio, and that's what this section is about. And so the first thing I wanted to talk about is how to divide a line segment into two line segments with a given ratio. So the given ratio on this one I put is 3:1. That means that we have 4 parts. And to actually do this correctly, I would need to measure that and measure this line segment and divide it into 4 equal parts. But I am just going to eyeball it and do it like that. So I have 4 equal parts, and so point P gives a ratio of 3:1. And that's how easy this section can be when you look at problems like that. So the next page on 642, we're going to look down here at this one. Okay, so in this example, the ratio is 3:1. This says find the coordinates of P that divides the directed line segment from A to B and A to B in the given ratio. All right, and a directed line segment is just the segment between the 2 points. So we see here that there are 4 parts. And so we have this first point down here would be about, let's say here, A at -8, -7. And then B is at 8, 5 up here. Now, the first thing that I want to do is I want to know the distance between the x's and the distance between the y's, and we can do that using slope. So slope is y minus y over x minus x. So the distance between my y's is 12 and my x's is 16. Now, I know that distance, I'm looking for P to be 3/4 of the way, okay? So I am going to take my X and my Y, and I'm going distance, and I'm going to multiply it by 3/4. So if I do 12 times 3/4, I'm going to get 9. And if I do 16 times 3/4, I'm going to get 12. Now, so what I'm going to do is I'm going to take 12 and I'm going to add it to -8, and I'm going to take 9 and add it to my y. Because remember, this is the rise and this is the run. So when I do that, I get an x of 4 and a y of 2. And that, therefore, I have this ratio of 3 to this ratio of 1. Okay, so now turn the page. Okay, so look at number 5. And it says, find the coordinates of P that divides the directed line segment from A to B with a given ratio. Now, the first thing I want to do is just sketch this. So A is over here, -6, 5, and B would be over here at 2, -3. Now, I want a ratio of 5 to 8, which gives me 8 parts. Okay, so the first thing I want to do is find my rise over run, and I get 5 minus -3 which is 8, and I get negative 6 minus 2, which is negative 8. And I want a ratio of 5 out of the 8, okay? So 8 times 5/8 gives me 5. And the same for the run is also 5. Now, if I'm moving this way, going towards B, I want P to be on that line, I have to add 5 to this. So I'm going to get an x of negative 1. But I have to subtract 5 from the y. So I get negative 1, 0, which is where my point P is going to be. Okay? And 5/8 is just a little over halfway, isn't it? All right, now I want you to try 6 and then come back and check your answer. Okay, so if you did this right, you would get point P is at negative 2, negative 7. If you got any questions about that, ask me tomorrow. Okay, so 12.3 starts on 653, and they're using indirect measurement to find measures of things that are really hard to measure. And one of the ways they do this is with shadows. And if you turn the page, they give you a picture here and a problem, and this is, so let's see how this one works. Okay, so in this picture, you can read this if you want to, they want to try to find the height of the palm tree, which would be very difficult to do. And so what they're doing is they're going to set up a proportion, and they're going to measure the height of the tree and its shadow, compared to a I don't know what a meter stick, and its shadow. So I know that the palm tree is, and there's two proportions you can set up. You can say the palm tree is to its shadow as the meter stick is to its shadow, or you can do like I've been doing. Little is to big as little is to big. And if you notice here, both of these are going to have the proportions, the cross multiplication is going to be the same in both of these. It's just set up differently. So either way you want to do that, that works. And when you simplify, you get that the height of the palm tree is 4.5 meters. Okay? On this next page, here is Liam, and I want you to try this one and then come back and see if you've done it right, because we've done enough of these, I think that you can do it by yourself. Now remember, you can have set this proportion up any way you wanted to, as long as these two and these two were your cross multiplication. And so you should have gotten 21 feet high. Okay, so in this problem, they want to know how far across the gorge, okay, distance D is across the gorge, and in order to be able to measure that, they use similar triangles. So they identify, what they do is they identify a point J across the gorge, and then they walk 24 meters, and they locate a point, and then they walk another 42 meters, locate a point, and then they make a 90-degree turn, locate a point out here that's 35. And because they know those distances, they can solve for D. And so we would do 24 is to 42 as D is to 35. So we end up with 840 equals 42D, and 840 divided by 42 gives us a distance of 20 meters. And that's how you do that. So let's look at the next problem and see what you can do with it, and then come back and see if you've gotten the right answer. Proportion should look like that, and you should have a distance of 24 meters. And that is it. And I will see you tomorrow.